Good morning to all the students. So today we will learn solving problem, the distance, time, graph. Okay, chapter 7, graph motion. Okay, so today our main objective, our learning standard is interpret distance, time, graph, and also describe the motion based on the graph, right? So there are two main objectives. One is interpret distance time graph, and the other one is describe the motion based on the graph. Okay, let's proceed to the next. Okay, all right. So during your Form 2 or Form 3, your teacher always like to ask you who like to sleep in the class, isn't it? So the teacher introduced this formula to you. Dia suka tidur. Okay, the dia here represent distance. Okay, and the S here represent speed, and the T here represent time. So the speed is equal to distance over time. So when the teacher mentioned who like to sleep, actually it means that the teacher want you to memorize the formula using the triangle. It doesn't mean that you like to sleep in the class. Okay, so if I ask you what is the distance given speed and time, so if I give you speed and time, so you multiply. That means distance equal to speed times time. So okay, for this topic, because we want to interpret the graph, for the graph we have positive gradient and negative gradient. Okay, so in order to find the speed, we will find the gradient, okay, for the line. So we will take the vertical part is one. Let's say this is 5, okay, and here is 2. So the gradient is 5 divided by 2, which is 2.5, isn't it? So that is the gradient. So for this topic, we will say the speed is 2.5. Okay, so if you are having the line going down like this, so you have a negative gradient, right? So when you have a negative gradient, okay, so it means that the line will be going down, right? Okay, so the gradient represents speed. So it also means that we have positive gradient and negative gradient. So what it means by positive gradient and negative gradient, the positive gradient here, it means that is speed, okay, is positive. Okay, the negative gradient here means that it doesn't mean the speed is negative. It means that the direction, okay, right? The positive and negative meaning that direction, right? So if positive means that the direction from one place to another place, then if negative means that the direction is coming back. Example, this is your house, okay, you go to school, this is PGS. So the gradient here, if you find from the graph, you will get the speed, so it's positive. So if you coming back from PGS back to your house, your gradient that you get later on will be negative. It means that the speed is actually the speed coming back from the school to your house. Okay, understand that? So the positive and negative, it actually means that direction. It doesn't mean that you have to plus or minus the speed. Understand? Can I? Good. Okay. Next, we proceed to the next slide. So for this topic, we have two types of the graph. One is the distance time graph, and the other one is also distance time graph, but the shape is a bit different. Okay, so you can see that. So this is actually positive, then 0, then positive, right? I mean the gradient. The gradient is positive here, positive, here 0, here positive. Then here positive, here 0, here negative. So there are two types of the distance time graph. So we'll focus on these two types for today. Okay. Next. Okay. So let's interpret the graph. For this graph, you notice that the part OA here OA from O to A. Okay, OA gradient positive. So gradient of OA represents speed of motion. Then the motion of uniform speed. The speed is actually uniform. Meaning uniform means same. If 5 km per hour, 5 km per hour. Okay. Motion for a distance from S1 meter in a period of T1. Okay. So for this part AB, okay, you're having 0 gradient, and then no change in distance means that motion stops. Okay, motion stop, that means stationary. Stationary for the period of how long? So you want to know the time, you will take T2 minus T1. Okay, example, your T2, let's say is 8 seconds. 8 seconds. Then your T1 is 2 seconds. So you just take 8 minus 2. That means stationary for 6 seconds. Okay, understand? Okay, so from B to C, notice that from B to C here, B to C, okay, a positive gradient, motion continue to C. Okay, so this diagram shows a motion from O to C for a distance of S meter in a period of T seconds. Okay, understand? Can I? Okay, good. We proceed to the next. So for this one, how do you interpret the distance time graph? Okay, so from O to P, you notice that there is a positive gradient of graph motion for a distance of S meter in a period of T1 second. So this is positive, right? And it's a new uniform speed. From P to Q, you're having 0 gradient. So there's no change in its distance. So we call it stationary. Okay, for the period T2 minus T1. And for the Q to R is here. Okay, is this one. Okay, a negative gradient. Negative speed show that object move back, see or not, move back. Okay, to original place or move in the opposite direction so can. And then this one, for this one is actually to describe the journey. Motion of 2S. Why we say 2S? Okay, example, your S is, let's say your house go to PGS is 10 kilometer. Let's say lah, huh? So if you come back, also of course will be 10 kilometer, right? Okay, so the total distance is 10 plus 10. So that's why 2 times 10, 20. Okay, so the time still the same T. So motion of 2 times of the S meter. Okay, to and fro. Flow means coming back in a period of T seconds. Okay, the unit is very important. Please take note about the units. Because sometimes we always use kilometer per hours. We also use kilometer per minute. We also use meter per second. Okay, so please be careful when you solve the problem like this, especially the unit. Okay, next we'll proceed to the next slide. Okay. So with this, I think we will stop here. Okay. So thank you so much for your cooperation, and I hope you will enjoy the class for the next lesson, right? Okay. Bye. Have a good day. Okay. Enjoy your study. Take care yourself. Stay safe. Stay healthy. Stay study. Don't forget